Hi, in this section, you will learn about the basics of SQL fundamentals, how to easily access and retrieve data in databases using SQL. For the example in this section, you'll be using the data from Billboard music charts. This data is stored in the Billboard Top 100 Year-End table. Basically, this table stores the top 100 songs for each year from 1956 through 2013. To access the data, simply click the play button next to data. Alternatively, you can write the exact same query, select star from tutorial.billboard top 100 year-end, and click run. It will take a few seconds for the query to run, but when it's done, you see the results show up in the table below the query window. So let's go over each column in the table to understand more about the data. The first column, year, basically is the year of the song was listed. Year rank is basically the ranking of that song at the end of this year. Group is the name of the entire group that won, or this can be multiple artists if there's a collaboration. Artist is the individual artist name. Song name is the name of the song, and ID is just a record to indicate if the role is unique. Let's try to understand how data is stored in database. So data in databases is stored in a table like this that looks very similar to an Excel spreadsheet. Each Excel spreadsheet will have rows and columns. However, there are a couple of differences between Excel and a database table. In Excel, you can have multiple columns that have the same name. Like for example, in Excel, you have multiple columns that have the same name like year. But in a database table, each column must have a unique name. Another difference is in Excel, each cell in a row can be in different data type. It can be number, it can be string. While in database table, all data in the same column must have the same data type. This consistency is the main reason why working with databases is much faster, even though they hold a lot more data compared to Excel. So by looking at the Billboard Top 100 Year-End table, you can see clearly that year and year rank, the first two columns, is of the number data type, group, artist, song name, is of type string, and ID is of type 0. This concludes our introduction about the dataset, and in the next section, we start diving in and writing our first query. The key to understand SQL is to understand statement. A SQL statement tells the database what you want to do with the data. So here are a few of the basic SQL statements. Create table is a statement that helps you create a new table in the database. Drop table removed a table from the database. And select statement allows you to read data and display it. And usually a select statement is called a query. For this section, we would only focus on the select statement in order to read data from the database. Below is the basic syntax of our SQL statement. Select from. So the from clause indicates which table you want to query data from, and the select clause indicates which column from that table that you want to get the data. Let's start by looking at our table and write our first query. So let's go to the same table, Billboard Top 100 Year-End. When you look at this table, you see a couple of columns here. The first question you want to ask yourself is which data you want to pull from, and which column from that data that you are most interested in. So let's write our first query. Select from. The data I'm most interested in here is tutorial dot Billboard Top 100 Year-End. And the column I'm mostly interested in is artist and song name. And after that, you can hit run. And after a couple queries, it will display only those two columns from the Billboard Top 100 Year-End table. Note that the column names you select are separated by a comma in the query. If you want to select all columns in the table, you can use the asterisk sign like this instead of column names. Asterisk here means all. Usually people call it select star. And if you hit run, it will select all the columns in that table. The limit statement is useful when you want to filter to only see just a few rows of the table to get an idea of the data you're working with. A table can be of any size, from a few rows to hundreds of millions of rows. So instead of loading the entire dataset, this limit clause is a way to keep your query from taking too long to run. This is usually the first query you'll be writing when working with any unknown dataset. So let's go back to our tutorial and let's look at only the first 10 rows of our data. So I'll type tlimit 10, hit run, and instead of loading the entire dataset, it will only show me the first 10 rows. The limit command is always the very last part of the query. So the syntax is that you put limit and the number of rows you want to limit. In this case, if I want to change it to 20 and hit run, it will show me the first 20 rows of this table. The where clause is used to filter your data based on any condition that you specify. The where clause is used after the from, but before the limit clause. Let's go through some example. In this example, let's say instead of getting all the data, I only want to get all the song of the year 2013. So the way I'm going to write this query is select year, artist, song name from tutorial.billboard top 100 year end, where years is 2013. And if I'm running this query will limit the data to only show all rows in the data where the column year is equal to 2013. Let's do another example. Let's say I want to get only the first song, the number one song for each year in the dataset. How would I do it? Let's take a second and write it. Let's write the query. I'm going to change my condition is to year rank equal 1. And I want to see the year rank as well to confirm our condition. And let's only run this part. And that's it. It showed me only the number one song for each year from 1956 until 2013. The most basic way to filter data with where clause is using comparison operators. Here is the list of comparison operators you can use to specify in a condition. Let's take a look at a couple of examples. If I want to get all the songs after the year 2011, what would be my condition? If you take a look at this, my condition is going to be where year is greater or equal than 2011. If you run this query, it makes sure that we have all the data after 2011 and above. Let's go to the next example. If I want to get only the list of top 5 songs for each year, what would be my where condition? So my where condition is going to be year rank smaller or equal than 5. And this will make sure that I only get the list of top 5 songs, 1, 2, 3, 4, 5, for each year from 1956 to 2013. Besides working with numerical data, comparison operators can also work with non-numerical data as well. So let's say if I want to get all Taylor Swift songs, so my where condition gonna be where artist equal Taylor Swift. And if I'm running this, I'm gonna get all the songs belong to Taylor Swift. Let's do another example. What if I want to get all Adele songs? So I'm gonna change the artist name from Taylor Swift, right, to Adele. In this case, I'm gonna get all Adele songs. If you're working with string or text data, make sure to use the single quote around the original text, not the double quote. In the previous lesson, you have learned about comparison operators to filter data. However, we can only filter data by one condition. For example, in the first query, we can only filter any song in the year 2011. And in the second query, we can only filter any song belong to Taylor Swift. What if we want to combine all these two conditions? That's when we're going to need logical operators. The SQL logical operators allow you to use multiple comparison operators in one query. Here's a quick overview of all the logical operators. We will start with the first three, and, or, and not. And allows you to select only rows that satisfy 2 or more conditions. So in this example, I want to combine the 2 conditions on the top. I want to get all Taylor Swift songs of the year 2011. And the way I'm going to write this query is going to be like this. select from tutorial.billboard, where year equal 2011 and artist equal Taylor Swift. And when I run this query, I'll make sure the result gonna give me all Taylor Swift song in the year 2011. The next operator is OR. So OR allows you to select rows that satisfy either or of the two conditions. So an example of using OR operator is that I want to get all the songs that belong to either Taylor Swift or Adele. This is a perfect case to use the OR operator. My condition gonna be where artist equal Taylor Swift or artist equal Adele. And if you run this query, you get all the songs that belong to both Taylor Swift or Adele. You can also combine the AND and OR operator using the parentheses. In this example, I want to get all the Taylor Swift or Adele song in the year of 2011. So my condition is going to be where year equal 2011 and open parentheses, artist equal Taylor Swift or artist equal Adele, close parentheses. And if I run this, I'll get all the songs of Adele and Taylor Swift in the year of 2011. Finally, NOT allows you to select rows that do not match a certain condition. Let's go to an example. So in the previous example, using this query here, we get all the songs of Adele and Taylor Swift in the year 2011. What if we want to limit this list to only get the song in the top 20 Billboard? The way we're gonna do this is we're gonna add another NOT condition, which is and not year rank greater than 20. And when we run this, we'll limit our result to only the song in the top 20 Billboard. Like is a logical operator that allows you to search for a specific pattern instead of the exact values. And there are often two wildcard signs you're going to use with like. The first one is percent sign, and the percent sign represents multiple characters. The second one is underscore sign, and the underscore represents a single character. Let's go through some example. In this first example, let's say I don't remember the artist name, but I remember that it starts with Taylor. If I want to get all the songs that start with the pattern is Taylor, the way I'm going to write this is using the condition where artist like Taylor percent site, and this percent site here represents multiple characters after Taylor. And if I'm running this, you're going to see all the records that have the artist name start with Taylor. What if I don't want to get all the songs where artists start with Taylor? It actually ends with Taylor. So the way I'm going to do this is that I'm going to remove this percent sign in the end and move it to the beginning, so that the percent sign now will match all the characters before it and end with Taylor. So if I run this query, you see that now I get all the artist name that ends with the name Taylor. What if I don't remember my exact artist name? I just remember that it has the word Taylor in it. It can be first name, it can be a last name. How would I do it? So the way I'm going to do it, I'm going to add the percent sign at the beginning and the end of the word Taylor, so that it will match all the artist name that have the word Taylor in it. In mode analytics, like is a case sensitive, meaning that the above query will only capture matches with the word Taylor with a capital T. So to ignore this case sensitive matching, you can use the I-like function. So if you use I-like, you can change this to lowercase and you will have the same query result, ignoring case sensitive. So using the percent sign, I can match multiple characters. What if I only want to match one individual character? That is when I'm going to use the underscore sign. So let's say I don't remember my artist name. I just remember it can be Tom or Timmy. The way I'm going to do this is that I'm going to put where artist I like and then T underscore M. And this query will match all artist name that have the word T and M in it. So now you see the artist name can be Tommy, it can be Timmy, it can be Tammy. The in operators allow you to specify a list of values that you'd like to include in the query result. Let's take a look. So let's say I want to get all the songs in the Billboard top 3. The way I'm going to write this query is select star from tutorial.billboard top 100 yen And my condition gonna be where year rank in 1 through 3. Notice that this year rank here is a list. That means I only want to get all the songs in the top 3. And if I'm running this query, I'm gonna get all the top 3 songs for each year. Let's go to the next example. So in the next example, I want to get all the songs of either Taylor Swift or Adele or Usher in the year 2012. So my condition gonna be where year equal 2012. And the artist now it become a list where I want to get all the artists where the name is Taylor Swift, Adele, and Usher. Note that when you work with text data, you have to put the name in a single quote. And when I run this query, I'm going to get all the songs where the artist name is either Adele, Taylor Swift, or Usher. You can also combine the in operator with a not operator. So in this case, if I change my in operator to not in, I'm going to exclude all the songs in 2012 that is not belong to Taylor Swift, Adele, or Usher. So if I'm running this query right now, I'm going to get all the songs of year 2012, but excluding any song belong to Taylor Swift, Adele, or Usher. Between operator allows you to select only rows within a given range. Let's take a look. So in this example here, I want to get all the songs of 2012 in the rank from 5 to 10. So one way to write this query is that I'm going to put my condition is year equal 2012, and year rank is greater than 5, and year rank is smaller or equal to 10. This can give you songs in 2012 that from the rank from 5 to 10. But this way of writing is very cumbersome and not easy to understand. So you could actually change this condition, become year rank between 5 and 10, and you will have the exact same result. Let's go to another example. Let's say I want to get all the songs of Taylor Swift between 2010 and 2012. So now my condition gonna be select star from tutorial, done Billboard Top 100 YN, where year between 2010 and 2012, and artist name is Taylor Swift. And if I'm running this query, you see that I'll get all the songs of Taylor Swift between 2010 and 2012. So you can use this between pair with the AND operator to get any record in any specified range. When working with databases, you meet a scenario where some tables might contain missing values. And the missing values is represented as null, which indicates that the cell has no data at all. Let's look at some examples to understand more. So let's go to the same table that we work with, and let's check if our table has any missing artist name. And the way we're gonna do this is we're gonna add in the condition where artist is no. And if we run this, we find that we have 9 rows or 9 records that have missing artist name. So no is very useful if you want to find any missing data in your tables. And if you want to exclude the no record, you can combine it with the not operator. So not is frequently used with the no values. So in this case, if I change my condition from where artist is no to where artist is not no, that means I'm going to excluding all the no values in our table. The order by keyword is used to sort our column data in ascending or descending order. Let's take a look at an example. So let's start with our original table here. By default, you can see that the table is sorted by year or year rank. If we want to sort it by artist name, the way we're going to write it, order by artist. And this query will sort our artist name in the ascending order. Note that you have to write the order by between the from and the limit clause in order for the query to work. Let's limit our query to only 3 artists. So I'm going to add the where clause where artists in Adele, Taylor Swift, and Usher. I'm going to run this query. So now you can see that the result, the artist name, are now ordered alphabetically from A to Z, starting from Adele, next to Taylor Swift, and finally you get to Usher. Let's take a look at another example with numerical data. So let's change our order by instead of artist, we're going to change it to year rank. And now if I run this query, the query result now is sorting by the year rank instead of artist name. If you like your result in the opposite order, you need to add the DESC operator. This is short for descending. So if now I'm running this query, the year rank now is sorting in descending order. So we have seen an example of sorting by only one column, but order by can also sort by multiple columns. This is particularly useful if you want to organize your data by multiple categories. So here I can add in another column. I want to sort by year first, then year rank. So if you take a look at the query result below, so this query result here is first sorted by year, and then it's sorting by year rank. I can add in descending here. Now the query result make the most recent year come first, then it ordered by the year rank. I can switch this around, so instead of sorting by year first and then year rank, now I want the opposite. So you can see here now year rank is sorted first, and the year column is sorted secondly. Finally, you can make your life a little bit easier by substituting the number instead of column names. So in my query result, the first column is year, and the second column is year rank. Instead of typing out year and year rank, I can substitute these two numbers become 1 and 2. And if I'm running this, the query result going to be sorted by the first column, then the second column. So the numbers here are going to be corresponds to the order of a column in your select clause. And I can add in the descending order. So now the first column going to be sorted in descending order, and the second column year rank going to be sorted in ascending order. So this is the end of this video. If you enjoyed the video, be sure to like and subscribe for more tutorials like this.